The next topic in control flow is very important and very interesting because it replaces C's switch. So, do you know there is no switch in Rust? Let us see that. So, switch is very familiar to all the C engineers, right? And very easy to use. So, however, there is no switch in Rust. Rust uses something called match. And here the right hand side is C code and left hand side is Rust code. So we are going to highlight some problems of switch case, and to add a disclaimer here, the problems highlighted in the entire series is not to degrade C and highlight Rust, right? It's only to show that C comes with some problems and Rust gives a solution to them, and that's why Rust is so safe. So the safety aspects become very clear when the problems are evident. So then we appreciate Rust more. Okay, so we are all C lovers, especially me working on C for such a long time, and the same, the same kind of interest is what the same kind of interest or passion for Rust also should grow, because Rust is a very safe language, a very thought through language, right? So that is the only intention. So if you learn Rust in this way, then you'll never forget Rust. Okay, so the right hand side is C code and it's a very simple program. So there is an enumeration platform which has got 4 platforms, that is Windows, Android, Mac and Linux. Okay, and then the platform is initially assigned to say number 1, which is Windows, right? And the switch case checks for the platform and then matches with the case and then prints this, right? Similarly, all of this can be printed if the platform value changes. So what is the first problem? The first problem is C by design allows implicit fall through. So what is implicit fall through? It means the switch case need not have a break statement. So what does it mean? It means by design C is okay for 2 cases to share the same code. So it gave this as an advantage, like if used wisely, you don't need to duplicate code. So for example, some platforms may share same code, right? So there is no need to duplicate here one time and here one time. So in such cases, the break statement is omitted deliberately and fall through is made so that this case will fall through this case and execute set of logic here. Okay, so that is the reason why C gave implicit fall through. However, if by accident or by mistake the break is forgotten, it can have severe consequences, because in this case the compiler will not give any error. Okay, so just take this example, right? So Windows is here, it prints Windows, platform as Windows, then there is a fall through, it falls through this case and it prints Android as well, right? It prints Windows and it prints Android. So how will the user make out of it, right? What will the user make out of it? So whether this is a Windows device or an Android device or something which supports both of them. Okay, so it printed both Windows and Android, right? So which is invalid. The device can have only one of the operating systems according to this logic, right? That is one problem showcased. So in some cases, assume a platform dependent code running here, right? So for Windows, say some calibration is running, right? Say audio calibration. So the audio calibration logic is very much dependent on the hardware. So if that logic is already executed here, and because there is no break here, it falls through and falls to the next case and also executes all the calibration logic. Assuming there is calibration logic here, it executes. So that means this calibration logic is overwritten by set of calibration logic for Android. So what is the result of this mistake? A bad audio quality, or maybe there might not be any output from audio, right? It can be some garbage, right, with lot of noise and all of that. So the because of the mistake, the errors can be subtle and very complicated, right? So this is the second one. The next one is basically that default is not mandated in case of C switch, right? So default is provided in C's design, but it's not mandated. See, if there is no default case, there is no compilation error at all. So we just now compiled it without a default case. It compiled fine, right? So now let us make it give a random value platform as say 10, which is not even present here. So let's compile and execute. See, it silently did not give anything. So this is a silent bug, right? When code base is very large and all these parameters are filled runtime, it's very difficult to know what's going wrong because it silently came out without doing anything, right? So these kind of bugs are common. The next one problem with C's with C's switches that the condition can take only integers, right? It cannot take anything from apart from integers. So that's the third limitation we can say of C's switch case. So assume that we'll remove Linux also, right? Not all cases are covered, but still if we compile this, C's compiler has no problem with this. It compiles fine. Okay. So missing a default case or missing an actual platform value, it has no problem. Or assigning this to an invalid value, it has no problem. And this compares, this compares only integers. Okay. Now let's see the equivalent of switch, but yet so powerful in Rust, that is match. So first let's cover the syntax of match and then let's see its power. So match is the keyword to use. It's an alternative to C's switch, and match, this is the expression to match. So this expression is basically matched to the left hand side of the arm. So how this has got switch case? Like this, match has got several arms. Okay, several cases, every case is exhaustively handled. So in this case, what happens? The left hand side of the first arm, right? This is the first left hand side of the first arm is the matching expression, and if this matches, the right hand side is executed, and these two are separated by something called a fat arrow. Okay, this is a symbol for fat arrow, and each of these arms are separated by a comma. Okay, let's compile this code and see. So similarly, we have commented out the Linux and Linux here, right? So this also has got 4 components here: Windows, Android, Mac and Linux. So how we removed Linux? Let's remove Linux here as well, or comment it out and see how it compiles. See, if you see here, it gives a compilation error and stops the program. It says, hey, go ahead and add Linux, and you can add any to do there. Make sure that the left hand side is there and it doesn't bother about right hand side. It says you can add whatever you want. So let's go ahead and add it here. Platform Linux. So it compiled fine. So this is a warning because Not all cases are handled, right? It's fine, we can ignore that warning. So it printed Windows. So what is the first power? The first power is that match cases are exhaustive. It wants every case to be covered explicitly. Okay, so that is match case in match control expression in Rust follows exhaustiveness. That means all the cases need to be covered. Okay, now let's comment it out and cover the Linux in default case. So how is default given? So in case of C, default is given by default keyword, right? In case of Rust, it is underscore. So underscore means for all the cases that are not covered here, it will fall here. That is the default case. Now just with the default case, let's compile and see if it compiles. See, Windows is again printed, it compiled fine. Okay, that is the second thing. And what's the third thing? The third thing is that, so in case of C, this can only be an integer, right? But here it can be very powerful. It can be, very powerful expressions, powerful pattern matching expressions. Okay, or it can be some ranges or multiple alternatives, or it can be any enumerations, or it can be tuples or structured data. It can be many things. Okay, you can match so many things here with this. So this makes it very, very, very powerful. Okay, and next one we will see one more thing. Okay, so instead of P1 assigned to Windows, like how we assign 10 here, let's try to assign 10 here and see. Okay, so this is of type platform. Let us explicitly make it platform and just say 10. Okay, so now let's compile this code. See, when you compile this code, what happens? It says, hey, expected is platform but found integer. It stops here and there. It exactly knows there is a type mismatch. It doesn't take any random integers for this, right? So it is so safe. So it doesn't give any scope of errors. The compiler is our best friend in Rust. All the problems are solved in compile time itself, right? The next one what we can see is another thing similar to this match. Let's have another match which produces a value. So in case of Rust, match can also produce a value. Say let's say let number equal to 2. Okay, and let's say let message, again this is a let binding. So let's say match the number. Okay, let us close the right hand side now so that we get more space. So if it is 1, then fat arrow, let's say 1. Okay, then similarly, let's say if this is 2, let the message be 2. Similarly, if it is 3, message be 3. Or we'll have the default case. We'll say, hey, if it is default, just say other. Okay, and let us close the binding. So here match is there, match is assigned to message. So what does it mean? It means the result of match is returned to message. That means when the match number pattern matches with the left hand side 1, 2 or 3, the right hand side is returned to message. And now let's print the message. So what are we learning here? We are learning that match can also return result. Let's compile this code. we can ignore the warning, and it says message equal to 2. So what does it mean? So C switch and Rust match both provide multi-way control flow, but Rust's match is very powerful. So it can extract data, right, and also allows pattern matching, and also does exhaustive checking, and it can also produce a value in a single construct. Okay, single construct. I think that's all for now.